Okay, the last topic for this section is even and odd functions. Now, an even function is a function that an even function, there are a couple of things. One is it has symmetry with respect to the y-axis. So for example, y equals x squared would be one example. So that's one of the properties that it has. The definition, though, is a function is even if f of negative x is equal to f of x. So x squared, absolute value of x, and cosine x are all good examples of that. Let's look at them on Desmos. All right, so y equals x squared. You got that? We can see the y-axis symmetry. Y equals absolute value of x, and y equals cosine x. Those all have y-axis symmetry. And so those are even functions. Now, odd functions are defined similarly. An odd function, the definition is a function is odd if f of negative x is equal to minus f of x. And these functions have symmetry with respect to the origin. Now, symmetry with respect to a line is very familiar to everybody, lines of symmetry. Symmetry with respect to a point is not as familiar to most people. So I want to sort of explain what that means. An example function would be y equals x cubed. Now, if we were to graph that, I'm actually just going to graph it by hand here. Y equals x cubed looks like this, more or less. Now, when we say that it has symmetry with respect to the origin, what that means is if we take the origin, think of like putting a pin in the origin here. Say, put a pin right there. If we take this and rotate it 180 degrees, it's going to land back on itself. I'm going to attempt to do that. So if I take this graph and I rotate it 180 degrees, we wind up with something that looks like the original graph. And so that tells us that it has symmetry with respect to the origin, and therefore it's odd. Another example would be sine. Sine x, I'm only going to draw 2 periods of sine. It looks roughly like that. If you were to take this and rotate it 180 degrees at the origin, you wind up getting the same function back. So that's what it means when it says symmetry with respect to the origin. Another way of thinking of this is when a function's odd, diagonally opposite quadrants look sort of the same. This one's empty and this one's empty. So they're the same. This one and this one are essentially the same. That's not a very rigorous description, but the idea of picking it up and turning it 180 degrees, though, that does work. Let's draw one more that's let's draw another function that's odd. This would be an odd function. If I take this and I spin it 180 degrees, it turns into the same function. Or at least it's supposed to be the same function. It's a little off, but I think it gets the point across. Now, Here's the nice thing about even and odd functions. For polynomials, if they're even, all the exponents are even. If they're odd, all the exponents are odd. And if it's neither, then that means you have a mix of odd and even exponents. And this is different from, we only have, of the whole numbers, they're either odd or even. We don't have any neithers. But with the polynomials, we do. With polynomials, we also have a both. But there's only one of those. The function f of x equals 0 is both even and odd. Let's look at some examples here. Let's see, switch over here to Desmos. Let's see. If we look at y equals, if I just put x to the 4th or x to the 6th or x to the 8th, that gives me something with obvious y-axis symmetry. If I put in x squared plus x squared plus 1/2, or no, let's do 1/10 x to the 4th. Notice we get this crazy looking function that also has y-axis symmetry. Oh wait, that does have y-axis symmetry, but it's not a polynomial. You get this thing. If I turn that around, as long as we have, as long as these up here are even exponents, what we'll get will be an even function, and we'll have y-axis symmetry. Now, what if I put a +1 on there? It still has y-axis symmetry, and that's because this is like adding 1x to the 0, and 0 is an even number. And that makes good sense because whatever this value is that we add on, that's just going to shift it up and down. That's not going to affect its y-axis symmetry. All right, let's put an odd function on here. Y equals x. That's an odd function. X cubed is odd. Put x cubed minus 3x. We get this thing. And you can look at that and tell that, yeah, if you were to put a pin in it right there at the origin, you could rotate it 180 degrees and it will land right on top of itself. That's actually just a better drawn version of the last example that I did on the iPad. X cubed plus x. That's also odd. X cubed. Whoops, I'm not sure how that happened. X cubed minus x to the 5th. Now that's going to be a big graph. It's still, when I say a big graph, I mean it's going to grow very fast. Let's shrink this down. X to the 5th times 1/11. There we go. That looks fun. But sure enough, that's an odd graph. Now, what if I add something onto it? Well, if I add a number, C, if I start sliding this up and down, it moves the symmetry point where the symmetry is no longer on the origin. This is still symmetric about this point here in the middle of the graph, but since that point is not on the origin anymore, it's no longer symmetric with respect to the origin. So as soon as I put a number on here, say like 2, now it's not even or odd. And that makes good sense because what we've got up here is we've got an odd exponent. This x has an odd exponent of 1, 5 is an odd exponent. But the 2 here is x to the 0, 2x to the 0. So that gives us a mix. And if we just put together, like right here, that's an odd function. If I put in plus x squared, what we've got now is no longer odd, and it's not even, because it doesn't have either type of symmetry. All right,